So with that, we will move at pace into our first panel session. The first panel session will be looking at the hydrogen share. So how far can hydrogen tackle emissions by 2050, and what are the different mixtures that we'll be picking up? With us as moderator for this panel is Ivana Jemelkova, Senior Managing Director of FTI Consulting. Ivana is a leading light in the hydrogen industry. She has more than 15 years experience working in energy policy, both in Brussels and in Washington, DC. And I will introduce Ivana now to introduce the panelists. Ivana.
Brilliant. Thank you, Dominic, and thank you all. An absolute pleasure to be here with you today. And can I say, wow, what a way to kick off this summit. I think we're all so inspired and humbled to hear Robert's incredible stories of saying yes to the challenge and leading the charge, learning from failures, and really persevering to turn dreams into reality. So obviously we're humbled to go in with our panel now, but let's keep going with the theme. Let's keep going with everything was difficult before it was done, and really talk about the specifics. So how do we actually decarbonize aviation? How do we get it done? What are the priorities? What concrete actions do we need to take today? And we're incredibly lucky to have with us some of the world's top experts who will help us answer these questions. I want to make sure that we invite everyone on video. I can see Rob, James, excellent, Keith, Richard, everyone's with us. So let me turn to our first speaker right away. Professor Rob Miller. Rob, you're a professor of Aerothermal Technology and director of the Whittle lab at the University of Cambridge. And you recently co-authored a very comprehensive report looking on the prospects of hydrogen in aviation. So over to you to share a few key takeaways. And perhaps could you tell us a little bit about some of the key unlocks for delivery? So what do we need to get done? Over to you, Rob.
Thank you very much, Ivana, for the kind introduction. So yes, I want to tell you today about this report, the Target True Zero report with the World Economic Forum, and a bit about the modelling behind it and what's important about it. So the model that it's based on is called the Aviation Impact Accelerator, which is a model that's a team of experts, about 100 experts around the world, who are building evidence-based whole system models for tracking and accelerating the pathways to zero carbon. And these models are unique in two ways. The first one is that they include a full life cycle assessment, from the energy and the climate impact of building the wind turbine through all the fuels right the way up to the flight and the climate. And the second one is they include all climate impacts. So not just CO2 in flight, but soot, water vapor, NOx, contrails. So both of those dimensions, and the models track uncertainty. So earlier this afternoon, I thought I'd run the model in 2035 on a transatlantic flight. And I think this illustrates the opportunity that hydrogen gives. So I ran the flight, London to JFK, and today, that flight, one economy ticket is 21% of a UK household CO2 equivalent footprint. Now, in 2035, it came back with two solutions. Both of them are below half that impact. And the first one is hydrogen combustion through a jet engine. And the second one is a synthetic fuel, effectively capturing carbon, electrolysis for hydrogen using the Fischer-Tropsch process. The reason that they're only half is because the contrail is still included in both those flights. Now, where the difference between the two occurs is really in terms partially of cost, with hydrogen being about 50% higher ticket cost and synthetic fuels doubling the ticket cost. But the real impact is in terms of the renewable electricity requirement. So the synthetic fuels, because of the complexity of making the fuel, requires for that one single economy ticket 140% of an annual household electricity bill in the UK. And the hydrogen is about 80%, about half that value. So you can see the difference there. Hydrogen has a key benefit that it's about half the electricity requirement. And up to 2035 and past, when renewable electricity is going to be very scarce, hydrogen gives us that real advantage. Now, I'd like to just quickly mention two of the unlocks from the report, and you can go to the report if you want to see more, and I think they're the most important for today. So the first one is developing lighter fuel cells. Now, this is really interesting. It's an incredibly non-linear effect. If you take all of the aero technologies today and you design an aircraft with a fuel cell with a system weight of about 1.5 kilowatts per kilogram, which seems reasonable, you will only get a plane that flies 1,500 kilometers, and it will burn 50% more energy than a kerosene aircraft per passenger kilometer. However, if you move to 2035 and you look at the way the industry is predicting those aero technologies will change, and you put them together, you get a very non-linear response. In fact, you can get an aircraft that will travel above 4,000 kilometers with only 20% greater fuel burn today. So you can see this incredibly non-linear effect, and I think fuel cells are really going to gain advantage as we start combining them with these aero technologies. Finally, I'd like to talk about the effect of designing hydrogen planes specifically for hydrogen. And this is a real problem, because if you retrofit a kerosene aircraft, a jet engine aircraft with hydrogen, because of the volume of the hydrogen, it pushes passengers out and the fuel burn per passenger kilometer jumps up a lot. If you actually properly redesign the plane for hydrogen, this volume limit is not a constraint anymore. And actually, within the uncertainty bars of the model, kerosene and hydrogen flights are about the same energy burn per passenger kilometer. And this is over any range. So there's a sort of a popular myth that hydrogen can't do long range, and that's wrong. And finally, there's some very interesting work going on at the moment on advanced hydrogen cycles, making use of the cryogenic hydrogen, that energy stored in the liquefaction process in flight. And that offers the potential in hydrogen jet engines of lowering the energy fuel burn per passenger kilometer by up to 30%. So that would be a marked advantage over kerosene aircraft. So that's about all I have time for in the sort of opening statement. But if you want to know more, please go to aiazero.org and you can download the report and have a go on the model.
Brilliant.
Thank you
so much, Rob. Really appreciate this very clear introduction, and the mission is clear. Let's talk about the equipment we need to take on the journey, and I want to zone in on the point on fuel cells and technology trajectory. So we have with us Keith Wipke, who's a Fuel Cell and Hydrogen Technologies Program Manager at the US National Renewable Energy Lab, NREL. Keith, where are we in terms of fuel cell development? Is that the big challenge ahead, or how do you see these issues at NREL?
Yeah, and thank you, Ivana, and thank you, ZeroAvia, for the opportunity to speak to this audience. Definitely humbled and inspired by our opening speaker. Relative to fuel cells, you know, PEM fuel cells have been under development for over 20 years. And so they've gotten pretty good for the car applications they were developed for. We're now doing research, some tweaks to make them better for heavy duty trucks, specifically things like higher efficiency, because the fuel cost really matters, long durability, like 1 million miles, as well as, you know, allowing a little bit maybe of a higher cost because it's their workhorses as opposed to just the car getting you to and from work. And so there's been a lot of development there. I think the progress will continue there. For aviation, obviously there would need to be some additional tweaks, right? I mean, you're dealing with a less dense oxygen in the atmosphere at higher elevations. Mass matters a lot more than it does for ground vehicles. But I think, you know, the trajectory is a good, optimistic one here. There's a lot of progress that can be made quickly. I think really the biggest challenge right now for hydrogen in aviation is the same challenge for hydrogen on terrestrial uses, which is lowering the cost. And this is why the Department of Energy has launched the Hydrogen Shot, which is a 1-1-1 goal, $1 per kilogram of hydrogen within 1 decade. And so this has really inspired us all to focus on this as a key enabler to make hydrogen more ubiquitous in our energy system. And so that would not only benefit trucks, but aviation, shipping, and so on. And so that is really the challenge right now that I see standing in the way of a lot of different applications for hydrogen, is lowering that cost. Now, we do have a couple things blowing the wind at our back here, such as the Inflation Reduction Act that actually was mentioned earlier, which includes up to $3 per kilogram for low carbon hydrogen, very low carbon hydrogen. And that could basically take 5 years off the 10-year journey that I just talked about, not technically, but economically. And so that's a real game changer. I think also scaling up across the world will make a big difference. We've got the hydrogen hubs activity in the United States, hydrogen valleys, and other activities across the world. So I see a lot of opportunity for a combination of technology improvement for the fuel cells, lowering the cost of hydrogen, and then just generally scaling up so that when we have this clean hydrogen, we also can move it around efficiently, whether that's pipelines or distributed generation. But we really need to make sure that we don't forget that connective tissue between the production and the end use. So I'm very optimistic about where we are. A lot of things are lined up now in a way that they haven't been. I've been working in hydrogen for 20 years, and I'm the most optimistic I've ever been about where we are and where we're going with hydrogen.
Brilliant. Thank you so much, Keith. I really appreciate the perspective. And that gives us the mission. That gives us some information on the challenges ahead, some information on the equipment that will aid us in our mission. And I'll turn to James Mcmicking with ZeroAvia. You lead the company's strategy. So I'm just so curious to hear, how we connect the dots between where we need to go, where we are today. Can you share a little bit about the progress that's been made and where you see some of the key challenges and opportunities, picking up on some of the themes teed up by Rob and Keith?
Sure, thanks, Ivana. Yes, huge topic. I'll try and condense it into a few minutes to keep the pace here. I mean, the interesting thing from my perspective, having observed the sector over the last decade, is the progress and the acceleration that's happening around the topic of how do we get to net zero 2050. And really, in particular, the last couple of years, the generation of these pathways, these roadmaps, a number of different bodies generating these national bodies, such as the Jet Zero Council and Sustainable Aviation Group in the UK, in the United States, similar roadmaps from the US Aviation Climate Action Plan, and then industry bodies, Mission Possible Partnership, IATA, and they all take on slightly different flavors in terms of how they see the different technologies combining. And it sort of depends where you sit in the sector as to the sort of flavor you get out of it. So broadly speaking, you've got some camps that sit in, we're in the current technological paradigm between now and 2050, and it's really about how we make that as efficient as possible and how we rely on different fuels to minimize climate emissions. And then you've got a different camp which is looking ahead to the next technological paradigm, recognizing that actually something is happening. These technologies are reaching the point where they can be adopted, and we can make a switch into a fundamentally better world for aviation. And you get sort of flavors in between the two. So these roadmaps tend to combine key elements, technology that I've mentioned there, so better, more efficient engines, or altogether new engines such as hydrogen electric powertrains or hydrogen combustion engines. And then different types of fuel. So sustainable aviation fuel, which is either a biofuel or an e-fuel generated from electricity and hydrogen and the carbon capture from the atmosphere, which Rob mentioned, and then hydrogen itself, which can either be combusted or again processed electrochemically through a fuel cell to generate power. And so these are the sort of different blends that we're seeing coming together in these roadmaps. But I think there are a number of things to consider when you look at them. First of all, a lot of them don't really account for the full emissions impact from aviation. So Val mentioned in his piece at the beginning of this summit, and Rob just mentioned now, the non-CO2 effects, the nitrous oxides, the contrail emissions. And most of these roadmaps do not account for these things. And at the end of the day, what we're on is a mission to reduce climate warming. It's temperature that matters here, not just CO2. So there's a sort of focus there that's perhaps absent from a lot of these roadmaps. Second, and this connects to something Rob mentioned as well, the roadmaps don't really account for the economic disparities that we're going to see emerging between these technological solutions. So, you know, as Rob mentioned, power to liquid fuel is going to involve a lot more energy, and it's going to involve a lot more capex in the generation of that fuel. And ultimately, it's going to be used through an engine that is less efficient than alternative ways of using hydrogen directly with less capex, less energy to generate thrust. So that's going to stack up in a big cost difference. And most of the roadmaps aren't really thinking about how that's going to change the trajectory of that technology mix into the future. Both of those points mean that the policymakers have a tough challenge on their hands, right? Because we need to create a level playing field for all of these technologies to ensure that industry is being encouraged to shift to the best possible solutions as far as the climate is concerned. So that's a key thing that we need to be getting right, and why the conversation in forums such as the Jet Zero Council is so important to the sector, because that's how we inform the debate. And I would say, you know, particularly within the UK, the desire to understand that at a policy level is really encouraging. So already talking about things like non-CO2 effects here, I think the UK is taking somewhat of a leading role in that respect. And then finally, you know, this idea that the transition is going to be costly. I think most roadmaps are predicting, you know, higher ticket prices, higher operating costs, but it doesn't necessarily have to be the case. Indeed, when you look at end-to-end life cycle of some of these alternative technologies, such as we see for hydrogen electric, actually it's possible to reduce costs and deliver on a zero carbon, zero emission solution. But one thing that you get consensus across all of these roadmaps on is the massive scaling up of renewable infrastructure that we need, because fundamentally this is all about effectively electrifying the sector. And the fuel that we use, whether it's hydrogen or power to liquid kerosene, is just a medium by which we connect aircraft to that renewable infrastructure as efficiently as possible. So hopefully that's a reasonable couple of minutes that I've used up there to inform the debate.
Fantastic. Thank you, James. You've covered a lot of ground there, really a number of different options, and they have important benefits and drawbacks. So your point on being really thoughtful and comprehensive in terms of our consideration is very well taken. And I'm glad that we will close this initial round of questions and answers with Richard. Richard Moriarty, you are the CEO of the UK Civil Aviation Authority. So wonderful to have with us a regulator, the person who's in charge of the land that we're hoping to walk. How do you see the mission of decarbonizing aviation, and how are you preparing for flying hydrogen?
Yeah, Ivana, thank you, and big thank you to fellow panel members here, but also Val and the ZeroAvia team for inviting me this afternoon. ZeroAvia is a very important and strategic partner to the UK Civil Aviation Authority. We very much see hydrogen as part of the future mix for net zero, as James mentioned. And I think actually what I'm really keen is over the next few years, for particularly in the UK, the debate to move away from what is a narrative weakness in aviation around the guilt of flying and the carbonisation of flying, actually to a good news story, which is a tremendous opportunity for innovation here. You know, aviation can lead the way, and there's a lot of good work being done. It's not quite cutting through yet to the public, but I'm hoping that day will come, and I'm really keen that the regulator in the UK supports that journey. I mean, obviously, where we come into it in a more sort of fundamental way is in terms of downstream applications for the public, the end user case, particularly around the certification journey, whether it be hydrogen, liquid gas, fuel cells, combustion. I think we start in a good place in the UK. Our legislative regime is technology agnostic. It's actually based on safety principles, which we see as quite a competitive advantage for the UK. And we did some work in the Civil Aviation Authority about a year ago, and I can post a link to the report, just looking at the legislative framework. And we don't see any barriers there for hydrogen to be brought to market, not from the statutory framework. Of course, the main thing that conditions market entry and the downstream application is around the regulatory certification, which is what we do. And I'm really keen for this not to be seen as a sequencing game where everyone works out the technology and the regulator sort of comes along at the end and then sort of certificates and goes through a process. I think it's really important that the regulator partners with industry along the way and is involved upstream. I think that's to the benefit of the regulator in terms of learning, and we're all learning here. And I think it's also to the benefit of industry as well. And some of that we've actually done with ZeroAvia. And in terms of what that might mean, I think there's a couple of things here that's really important to us in the UK. The first is that we as a regulator are able to provide services to folk to help them prepare for regulatory readiness. We call them sort of innovation advisory services, which are provided by a part of the Civil Aviation Authority. But it's really important that we use this capability in order to allow people to experiment and have permits to fly. The point earlier that was made strongly resonates with me, which is we must learn. And actually, sometimes we can only learn by doing. And actually, where we are working with an organization that has a really good safety culture, a really good transparent learning culture, and has high confidence with us, actually, we can do some things. We can experiment, we can have trials and build out from there. And I'm very keen to create those conditions in the UK for hydrogen flight. Later on, of course, we will need to think about the more formal regulatory requirements around certification. We're already thinking about that now. We've built our teams. The UK is now outside of the EU and the CAA is outside of the EASA system. But I should stress that although I'm really keen for the UK to be a leading place for this innovation and hydrogen technology amongst others, I absolutely appreciate that everyone looking to do that will want the technology to passport and be recognised in other jurisdictions. So I think it's really important that as regulators, and the CAA believes this, that whatever we do by way of certification, it can be validated, it can be approved, and it can be passported into other jurisdictions, particularly those big end user markets, whether it be North America, Europe, Southeast Asia, etc. So that's why, as part of this, as well as working upstream with innovators and companies, and also building the resources needed for the technical certification, I'm also keen as a regulator, we're working closely with partners around the world and our fellow regulators to make sure that when we can certify, that can be validated and accepted in other states. So I actually see a bright future for hydrogen, and I see a bright future for hydrogen in the UK. I'm keen that we don't take bets on particular technologies as a regulator, but we do have a key enabling function that where we are working, as I said, with companies that are looking to innovate, that have really good safety cultures, we can support them in that journey and in that growth. So I do hope that we will all see a day when, you know, I turn up at aviation conferences and the press are there and, you know, you feel on the back foot because of aviation's carbon contributions. I hope the day will come very soon where actually all of us will be on the front foot with a really proud story to tell, because we've changed the dial in the public's consciousness when it comes to net zero. So that's all from me by way of opening, Ivana. It's really good to be here.
Fantastic. Thank you, Richard, and really appreciate the point on the huge opportunity ahead and the importance of collaboration and working together to get this done. This is decisively a team sport. This is a mission that we need to sort of undertake together across regulators, policymakers, businesses, entrepreneurs, academics and scientists. So really wonderful way to bring it all together and link back to the amazing story we heard at the start. I see we have about 12 minutes left, so let's do a quick sort of rapid fire round of questions on some of the key themes: speed, scale, challenges, actions, and then also invite our audience to jump in with questions. Feel free to use the Q&A function at the bottom, or write your question into the chat, and we'll try to bring in at least a couple and or have them answered in writing if they're perhaps a bit more specific. I saw we had someone on links on whether ZeroAvia would like to do something in Berlin, so that sounds exciting to me, but I'll let the team answer that. So let's kick off with speed. James, and I'll turn to you. The scale of the challenge is clear. What can we do to go faster? Okay, be as quick as I can. I think, first of all, getting on the right footing, and we're not quite there yet. And you know, if one thing you should take away from this conference so far, or the summit so far, is we do have an existential threat to this planet and to this industry if we don't do something quickly. Now, we've been through a few years where we faced an existential threat, and we did some stuff really, really quickly. So it shows what is possible when you act with real purpose. And I think we're still on a transition to behaving and thinking in that sort of way. And what that means then is unlocking the technology and the engineering that Val talked about, because that's where the solutions are going to come from in all of this, and really doubling down and backing it. And again, you know, we saw through COVID what was possible by placing multiple bets on different vaccines, on different ways of getting ventilators produced, and very, very rapidly in world record beating timescale had those solutions. And you did it, you know, not knowing what was going to work. And in some respects, we need to take the same attitude here. Really get behind the engineering and the technology, go build it, as Richard said, and learn as fast as we can from that process. So I think, yeah, that's how we get there fast. We need to put confidence into the market as well, alongside all of that sort of supply side intervention, if you like. You know, tell people that, you know, this is going to come. This is the policy framework. We're going to clear the way for these technologies to be introduced into the market once they're ready and safe. So I think we can start to give the market, you know, confidence, and then it's really getting out there and doing it, building these things, which of course is what we're doing at ZeroAvia. Perfect. And I'll pick up right away on the theme of policy action. Rob, what are some of the key actions policymakers can take today to unlock decarbonization of aviation?
Thank you, Ivana. So policy is obviously key, and good government policy is going to be key to accelerating this process. And the aviation sector is quite different than other sectors. It's incredibly technology rich. And that means that the technology is developing live with its application. And that means that any pathway you publish will be out of date by the time you publish it. And so government needs interactive tools by which, as technology and science changes, they can see the consequence on the future path, the cost, the rollout, where to invest, and the uncertainty and robustness of their solutions. And I've got a great example of this. We were contacted, the Aviation Impact Accelerator, by the Department of Transport, who were developing their SAF mandates for the UK. And they explained to us what they were doing and how they were doing it, and we helped them. And then we produced an app, a tool that was data mined from our key tool that helped them. And there were hundreds of emails back and forth between the DFT and our teams. And we honed the tool, we changed the tool, they changed the way they thought about the SAF mandates. And I think the consequent SAF mandates that will come out are far more technology and science informed than they would be. And they can therefore evolve over time. And we need to do this more with government. With technologists, we really need to engage with them at this whole system level to help them make better policy. And I think that's how we'll accelerate change.
Excellent. Thank you, Rob. And I'll build on that and move on to Richard. Richard, you spoke about the importance of partnership and really walking the walk together. The path to scale is not linear, and there will inevitably be setbacks, because as you correctly pointed out, this is an area where we need to innovate, experiment, figure out which path is a no-go and which one is a go and will actually get us to our goal. So how important is partnership with industry in managing all of this? And I see that in our Q&A function, we have a question about the certification base for hydrogen. How important is partnership when it comes to really going the full journey from test flight to a certified, standardized, scale deployed product?
Yeah, thanks, Ivana, for the question. I mean, my answer really builds on what Rob has just said. I think it is a partnership of co-creation here. It's got to be, and the regulators and policymakers, in my opinion, have to be involved upstream. And although this is a very unregulatory thing to say, I think we've got to set the conditions to try some stuff. And we've got to learn fast and we've got to evolve, but we've also got to fail safely and recognize that there will be setbacks. I mean, you know, the price of progress is there's going to be setbacks, and providing we are assured on safety throughout, and we can work with partners on that. And, you know, Val and the ZeroAvia team, you know us well from working closely with them on this. You know, I think it's important that regulators create the conditions that people can trial and try some stuff, and then the system can learn. I mean, I'm all for, you know, theoretical and laboratory learning, and it certainly has its place. But actually, aviation is a practical industry. We learn so much by doing stuff, but that can only work if people are collaborating and they're doing it in partnership.
Great, absolutely right. And Keith, I'll let you close here. You are a voice from the US, from an American national lab, and obviously there are some important differences in how different governments and markets choose to approach this issue. Could you tell us a little bit more about that? And with your permission, I would add on a question that is now appearing in the Q&A window, and that is all about how do we actually get the hydrogen that we need to power these flights? What kind of hydrogen? How do we ensure that it's clean? And again, vast differences in how Europe and the US, for example, are choosing to answer this question. So if you could elaborate a little bit on that and share a bit of a perspective on the differences.
Yeah, I mean, there's a saying that all politics is local, right? And I think in hydrogen production, locality and geography really matters. You want to use the resources that are available to you, and now we're kind of transitioning to the resources that are available to you that also can give you a low carbon pathway. So, you know, we also have in aviation to look at the network, right, of airports and where vehicles fly. I think we have a lot to learn from California in the United States. They've successfully navigated the chicken and the egg issue to start from, you know, just a few cities to connecting the cities to basically covering most of the state of California, and now filling that in with capacity to handle the growth. And, you know, they've got, I just checked, over 14,000 fuel cell cars sold and 56 hydrogen stations. So clearly not as ubiquitous as gasoline, but that growth and the kind of, you know, figuring out where do you start, where do you connect, and again, where do you get that low carbon hydrogen is really important. And so distributed, the one nice thing about hydrogen is it can be distributed production. So you can actually make it relatively close to where you're going to consume it and minimize that transportation distance. But it may also make sense in some cases to have a really big production facility and then transport that hydrogen. So it really gets down to local geography, local resources, and also the policies that are in place where you're going to be doing this.
Great, thank you, Keith. Very clear. And I see we're almost on time, so we'll do one final round of questions. I see we have a few themes emerging in the Q&A window and also on chat to do with e-fuels, specific questions on CAA's actions around hydrogen, and some questions around, you know, how can small businesses actually play a role here? So I'll let the team answer.
How to get my background on.
And or share additional information, but really for our panel here, a final 30-second answer by each of you. Obviously, we've covered a lot of ground here. There are so many things we could do. where do we start? Really, what is the one key thing that you believe we need to do today to move forward, and why? Pick one, only one. And I will start with Richard and then move around the room. Richard, what is the one thing?
I'll keep it simple. We need to trial some stuff. We need to learn by doing.
Very clear. Rob, we have not prepared the order, so I hope I don't catch you unprepared. Rob, over to you.
Not a problem. We need, key to this unlock is good governmental policy informed by science and technology. We need whole system tools which allow government to make better policy quicker.
Brilliant. Keith?
Yeah, I think we really need to focus on lowering the cost of low carbon hydrogen and look at the optimal pathways to get it from where we can produce it from renewables and other low carbon sources to where we need it. That's kind of the bottom line from my perspective.
Super clear. James, I'll give you the last word as the host.
Yeah, thanks. Yeah, I think echo everything that's just been said. I think it's about closing the learning loop as quickly as we can between technology and policy, because we don't want to get swamped in trying to chase perfect data. We're not going to have perfect data anytime soon. We don't want that to get in the way of moving the policy agenda forward and getting in the way of making progress on the engineering and technology. So let's just keep learning and doing as quickly as we can and iterating as an industry. That's kind of my takeaway.
Brilliant. Thank you all so much. I love how we managed to replay some of the themes from the opening in a slightly different way from our desks right now, but we're definitely working on all the big challenges ahead. So thank you so much again for spending the time. Congratulations to ZeroAvia and the team for bringing together some of the brightest minds and thinkers and doers in this space. And back to Dominique. Over to you.
Superb, thanks Ivana. Yeah, what a great session to open up. And I think it really teases up very nicely to our session 2, which is a timeline to zero emission routes, where we're going to hear from some of the airline representatives. And this is, we're going to take a quick 5-minute break. So we'll be back with you at 5 past the hour, ready to dive into that topic with our moderator, Roger Atkins. So back with you in 5 minutes. We're going to play some videos in the interim. But feel free to use the time to make a cup of tea or what have you. Thank you.